The topic of this lesson is working with camera movement. Now, moving the camera is pretty much the same as any game object. You just update its transform values, right? But there are a lot of other interesting things you can do with the camera. For example, in this lesson, we'll look at zooming the camera in and out to get a closer view of the action. So the easiest way to have the camera move is to just follow another game object that's already moving. And the easiest and most obvious way to do this is to simply parent it to that game object. So for example, we can parent our camera to the cube and thereby inherit its transform position, just like that. Oh, it also takes its X and Y position by default, so let's just put those to 0 to start off with. And I'll hit play and I'll show you how this works. There you go, it's following our cube. Right? Not the result we're looking for, but this is the easiest way you can get the camera to move and track a game object. So I'm going to hit Control-Z to undo these changes, right? Put the camera back to its own game object. So what I actually want to do instead is have the camera stay stationary under normal conditions until we engage the PowerUp, at which point the camera will then begin to follow the player and then stop following when we disengage the PowerUp. So we'll want to control this in code by creating a new script called, let's call it ZoomCam, and we'll put it in the Assets Scripts World folder. So new C# script called ZoomCam. And we'll just right away attach it to the main camera because it's going to be controlling the camera. We don't want to forget. And we'll open that up in Visual Studio. So the first things we'll need for the script is a couple of outside references. One is for the cube's transform so that we can make the local transform follow the cubes. And we'll also need the PowerUp Manager reference, or sorry, PowerUp Spawn. We'll need that game object reference so that we can look up whether or not we are currently in PowerUp mode, just as we had done with the teeth animation script, I believe. So let's just add those references like so, make them both public fields. So one's going to be a transform, call it cube transform, and the other one's going to be a game object, PowerUp Spawn reference, right? Transform. And now, after we save that, we can assign these public fields in the inspector. May as well do it right now so we don't forget. All right, so for the cube transform, we just do it as we did before with when we had the game object field, right? But now our field is considered only a transform. So Unity is smart enough to know we just want to get the transform reference of the game object, not the entire game object itself, when we're assigning it in this way. And of course, as we did before with the PowerUp Spawn, we'll want that reference as well. So going back to the script, we're going to want to write everything in a Unity method called LateUpdate, which we sort of touched upon in an earlier lesson when it was kind of misapplied, but now's the right time to use it when we're working with the camera in particular. This method behaves exactly like the update method. Exactly the same way, except that it executes after all update methods from all the game objects across the board have already been called. So one of the reasons why it's important to use LateUpdate for camera control is because there's the chance that the camera's update, if you're not using LateUpdate, there's a chance that the camera's update will run before the object it's tracking's update method runs, right? And that could result in a herky-jerky kind of motion or some other such problem. So here's my way of thinking about the logic behind this. Consider filming a movie scene. What's the rule of thumb for the camera operator? Do the actors try to time their lines so that they can finish before they know that the camera operator is going to move the camera? Or should the camera operator wait until the actors finish their lines as a cue to then move the camera? The answer is the second one, of course. The camera is, in other words, just a camera. It shouldn't have to, or it should have to wait until all of the information in the scene has been set, you could say, before it decides to move, or before the camera operator, in this case, the script decides to move the camera to follow the game objects. So just keep that rule of thumb in mind and use LateUpdate to ensure this is how your game executes, right? By waiting for everything else to be set in the update method that it may depend upon. Later on, we'll look at a similar problem that can arise from not using LateUpdate. Okay, so moving on, let's set up a Lerp method that takes in the from and to positions and lerps the camera accordingly. So let's create a private method. Actually, I'll just set up LateUpdate right now so I don't forget. And so we'll create this local method called camera lerp. And we're going to want the from position and to position for it to implement the lerp. So make a input parameter called from position and a vector3 to position as well. So this is going to be a vector3 lerp. It functions exactly the same way as the ordinary float mathf.lerp that we used before, but it takes in vectors and results in a vector at the end of that. And here we'll go vector3.lerp, and then whatever the from position ends up getting setting at the call to the to position that again gets set at the call. And right now I'll just put a value of 0.08 as the percentage between those 2 points, and I'll assign the output of that lerp to the main camera. So I'll go camera, that's the class name, and then the static property main to refer to the main camera, and then its transform position, just like that. So you may be wondering why I'm setting the camera's position through this static property camera.main. It's just to show you that this property exists, right? It's a handy way of accessing the main camera's transform anywhere in code because it's static, right? So in this case, we actually don't have to use it because the script happens to be attached to the camera itself. So we can just instead reference its transform.position as we've done before with every other game object, right? But nevertheless, we'll do it this way just so you remember that this camera.main static property is available. And now we're going to lerp differently depending on whether or not we're powered up or not. So in particular, we lerp towards the cube when we power up and away from the cube back to the default camera position when we're not powered up. So let's handle this in a conditional, calling the camera lerp method according to whether or not we're lerping to the player or moving back to default. So in LateUpdate, set the conditional as if PowerUp spawn reference dot get component, and we'll want the PowerUp manager, and then it's is powered. That's the bool we're interested in here for this conditional. So we'll want the cube position, so cube transform dot position, we'll set it to this local variable, and we'll take that, we will take cube position dot z and -10 because we expect the camera to be at -10. We know the cube is going to be at 0, so that's why we want that, because we're going to assign this to the camera. Now we implement our camera lerp method, or we call our camera lerp method, and we lerp from the camera main. Just pass that in. Transform, its current transform position, and then to the cube, right? We want to lerp towards the cube, so the cube position. Else, if we're not powered up, we want to lerp back to its original state. So we'll define that as a local variable called default position. New vector 3, and we'll just want to replicate where our camera normally is, which is the position for the transform position for the camera would be 0, 0, minus 10, and just reference that back in the camera lerp method, this time to lerp back to the camera's original position. So we'll again reference the camera main transform position. At this point, if it's zoomed in, that's what it will take in, all the way until it zooms back out to the default position, right? The end state of that lerp. If you need to go back to the lesson about lerps to refresh your memory on how this all works, go right on ahead. All right, so now let's see how this works. See if we can get a successful camera lerping effect whenever we engage teleport. Right, we're running out of PowerUp juice, but yeah, we saw it lerping. Yep, and when PowerUp runs out, it also lerps back to its original position. Okay, so that's a pretty good start, but what we really want to do is zoom in and out so that we can sort of have that as a more dynamic camera function. So to do that, we have to reference the camera's orthographic size to make it larger or smaller. So it's normally set to 3.6. Let me just cut that in half. Right? That's zoomed in at 1.8. Right? So we just need to reference and lerp this property. So back in code, we'll set that. So we'll want to add this to the camera lerp method's behavior by using another two input parameters. So let's call it float from cam size, and the other input parameter that we'll need we'll call float to cam size. Right? And within the method, we'll implement the orthographic size as the output of a float lerping. So to implement this, use mathf.lerp, because we're going to return a float and then set it to the cam size, which is a float. Reference from cam size to cam size. And so it all occurs at the same rate as the position lerp. We'll just reference that value that we used before for the percentage. And then we'll assign this to, try to predict it, camera.main.orthographic size. Right? Now here in the callers, we'll want to use those input arguments. So for the from, when it's zooming in, we'll want to create a smaller orthographic size. So first from, wherever it is at, the orthographic size, dot main. This is going to have the effect of smooth lerping, right? Because as the orthographic size changes, as we saw in the lerp lesson, it'll represent a percentage of the way between this from and then the 2 point, which will be, we'll want to end off at 2.5 for the orthographic size. I just figured that that's the best, most zoomed in state for this functionality. And I'll put that on another line so it's a little bit easier to see. And then when we zoom back out, we just go back to the previous or the default orthographic size. So again, try to predict what we input here for the arguments. 3.6, right? That's what it normally is. All right, so let's try that. Run that now. See if we get the zooming effect. Yeah, pretty good. Here I want to maximize it so we can get a little better glimpse of the action. There you go with the teeth chattering, animation and everything. All right, pretty good. So now the next most obvious thing to fix is to add an image for the bounds of the arena, right? We kind of saw that outer bounds of the viewable space that before we never saw, but now we do. So we're going to need to change that with an asset when the camera moves outside of our ordinary arena space. So let's parent a new game object to the background game object, call it arena, and set a sprite render image. I already made one, so we'll import that in a minute. And we'll give it a sprite render, and I'll put it on the background layer. And so it's doesn't really matter, but I'm going to make sure it's above the ice surface. At least that has a certain internal consistency, right? And for the asset, we'll want to import it to images world. So import new asset. There it is, arena box. Change that as we normally do to point. And I made it just the right size so that we don't have to mess around with its transform. It should work under normal conditions. It should be placed exactly where we need it because of its dimensions. And we'll also need to change here because it's, I'll show you. See, that's the outer bounds now of the arena box. So we'll also want to change the color. Actually, it's on the main camera here. We got that blue, so let's just put in this red background instead. We'll run this. I'll want to grab PowerUp just so we can quickly take a minute, but grab PowerUp so we can look at how the zoom is working. Get a longer glimpse at the camera, at the arena bounds. All right, pretty good. It looks like it's working. Now, as I mentioned earlier, not using LateUpdate can cause issues with the camera. So I want to show you an example of this with just a simple change in code. Let's store the zoom state within a bool in this zoom cam script, and we'll see what happens when we don't use LateUpdate. So let's make some temporary changes so we can see this in action. Actually, this will be a permanent change. We won't revert back to the way it is with this. What I'll do is I'll show you an easier way in which we can reference the outside PowerUp Manager script. We're not really interested in the whole game object that holds on to it, so we can just do it this way. We can say GameObject.find, and well, the problem with this, of course, is if you change the name or whatnot, you'll have to come back and remember to fix it here, but otherwise this will work just fine. And then once that's returned, we can just access the script component that we're interested in with just using a dot accessor and asking for get component to return the PowerUp Manager script component. All right, just like that. And we'll return that to a local variable, PowerUp Manager, of type PowerUp Manager. We'll call it PowerUp Manager, lowercase. And so that means we can just get rid of this right here. We don't need that anymore. Okay, so to illustrate what can happen if you don't use LateUpdate for camera movement, let's create a bool to store the state of our camera, whether or not to zoom in or not. So we'll call that isZoomed, defaults to false. And what we'll do is we'll create a conditional here. If input dot get key down key code Z. We're checking this in another script, of course, where the PowerUp is being engaged, but we're doing it here as well, just so I can illustrate this for you. And if the PowerUp manager is powered bool, also returns true. So if both of these return true, we simply flip isZoomed, right? Either zoom in or zoom out. Else, if not PowerUp manager is powered, make sure that isZoomed is false. All right, and here we simply just reference that state for isZoomed. If it's true, then do the lerping behavior that we previously coded. Now let's also put this to update, see how it behaves if we don't do it in LateUpdate. So I'm going to engage teleport, and nope, didn't work. We got the slowdown, but the camera's not lerping. See a little jerking out there. So that's a problem. Let's see now if we can solve it with LateUpdate. Oh, now it works. So why is this? Well, basically it's the same problem I mentioned earlier, but in this case, the isZoomed state depends on both the keycode.z returning true, this part right here, as well as the outside script's isPowered state being true, right at the same time as this conditional is being read. But what's obviously happening is these states are never both true at the exact same time. In other words, this update may have read the keycode Z as true right here, while the isPowered state has not yet been determined because its update method in the outside script must be running after this update has already run, right? So we need to make sure that the update method that controls the state of the isPowered bool in the PowerUp manager runs before the update for this script, for the ZoomCam script. And the only way to ensure that's the case, or at least the easiest way to make sure that's the case, is just to use LateUpdate, because then we know all the update methods have run for all game objects, right? One last thing I want to mention about this is if you try to run this on your end, if you don't get the same result that I showed, where the behavior is different depending on if it's LateUpdate or update being used, you can go to Edit, Project Settings, and you can set your script execution order here, which is handy. So otherwise you don't have to worry about this if you're always using LateUpdate whenever you have these execution order issues, but you can explicitly set the execution order here to solve those problems. But in this case, to get the same result that I was getting, just make sure that the ZoomCam script runs before the PowerUp manager, and then hit apply, and that will ensure that you'll get the same result I did on your end, just for testing purposes if you wish. All right, so now we can revert to how it was before. We'll retain this part, but otherwise we don't need all this stuff, or the bool. Just put that there. That's pretty much as it was before. Right, I hope all that makes sense. Don't worry too much about it if it didn't all make sense. Just remember to use LateUpdate for camera stuff. Otherwise, everything we did in this lesson is pretty much as we've been doing it all along. All right, so I think this is a good time to end this lesson. Great job, and I'll see you in the next video.